Hello everyone. In this video, we're going to show a methodology to turn any template into a form. This is not a public repo, but if you are a Python tinkerer or when the Supernote official plugin framework or SDK are released, you'll be able to build and customize a similar automation. My real project is for a niche industry where staff cannot easily use electronic forms on tablets. Instead, they use pen and paper, with the obvious inconvenience when it comes to extracting data. We're going to try to facilitate extraction by using Supernote tablets, though the methodology could be transposed to high-quality scans. Okay, for this demo, we're going to use PNG templates, though my script works with multi-page PDF. Here I downloaded from the web a budget template. I slightly modified it to add some comment boxes. This is a very basic template with input zones for the month, name of expenses, budgeted, and actual amounts. Another PNG I built from scratch is a basic invoice for a fictitious garage. This example is a little bit more elaborate because you can see that the page gathers information about the customer, the vehicle, the parts, and labor. Now, I created a notebook for my budget account month by applying the budget template, and I added some information for the month of September and October. Similarly, for the garage, I created a notebook garage invoice that I populated with some handwritings. So far, this is classic use of templates on the Supernote. Now, how are we going to make these templates ready for data extraction? The idea is that we're going to augment these templates with a mapping file. A mapping file is a notebook that is created using the same template, except that we add on top of each input zone we want to extract a text box. Each text box is not only positioned above a very specific area, but also contains a definition of that input zone. You're probably starting to see where we're heading. These input zones are fields of tables where the extracted information is eventually going to be stored. So to summarize here, every template is augmented with a mapping notebook that has text boxes above input zones. These text boxes contain field descriptions. Each text box stores two types of information: the exact location of a field input on a screen and the information about the field itself. Okay, so we're lazy people and we want the script to create a database framework for us based on our field description. This requires to have a notion of a data structure, but we're trying to make that syntax as simple as possible. At a minimum, you'd need to be able to identify distinct entities you have on a template. In the garage example, you'd need to understand that the template combines specific info about invoices, but also clients, vehicles, mechanics, parts, etc. In our description syntax, we're using dots to show how these entities interact. And of course, we indicate a field name, its type, etc. Some of the fields like total here are calculated, and we do need to put a formula in at least one of the cells. Now, just an overview of what is going to happen when we launch the script. First, it's going to look in a folder for notebooks with names ending with _map. This is our naming convention for mapping notebooks. For each such notebook, the script computes the file signature and extracts each template signature. Then it stores the location and page number of any mapped template in a registry. Then the script processes an actual notebook with handwritings. For each page, it extracts the template signature, then pulls the map saved in the registry. That's how it knows that for our garage invoice example, the mapping template is located at page 0 of a mapping file called nvmap.note. You can see, by the way, that I also have a mapping notebook with 69 templates, each a page of notebook created from a long PDF template. Here is what the interpreter gets from the text boxes from the garage_invoice mapping file. First, a list of screen location and corresponding table name and field name that we're going to use to pull from the recognized text output. Second, fields type, indexes, details on calculated fields. That's going to be used to create the Python data model layer and the backend database. Okay, the script has a notebook and a map. What else does it need? You guessed right, the recognized text. Here we're using Microsoft Computer Vision because it is very performant and it returns a recognized confidence level that we use to flag some data for human review. Now for the outputs. Here's what we get when intersecting bounding box outputs from our API call to MS Vision with our dictionary of screen location. And here is an excerpt of what the data model handles. The script also generates an ORM on the fly, ensuring that operations in the data model layer are propagated to the back-end database. In retrospect, the technical challenge of this project is more about defining the insertion and workflow process. In ideal input form design, the data framework is first built, then forms are designed with input fields, lookup drop-down, etc. When tackling the problem in reverse, one needs to take in consideration the sequence of updating, inserting, etc. But I am not going to dive into these details. The cool thing is that the algorithm is using the very generic objects created in the data model layer. Now, to shorten our text box's input, we're adopting a notebook naming convention. The name of the data extraction project, underscore, and the name of the primary table. For example, for my budget, the file containing my handwritings is named account_month.note. So the script infers that this is a notebook about account data extraction and that the primary table is called month. Similarly, for our second example, the notebook is called garage_invoice.note, meaning that it's about garage data, and the primary table is called invoice. All right, maybe one last technical comment. In this example, the backend database is SQLite and the Python data model is Django-like, meaning that you can later manipulate the data using the data model layer and easily build a web interface. Okay, enough boring stuff. It's showtime. Let me run the script in verbose mode so you can see the various stages. You can see that the account data extraction folder was created. Let's go back to show some outputs. Map registry querying, database creating, data coercion into the tables, etc. Now, this is not part of my project, but let's see what the recognized and computed data looks like when it is uploaded to the same notebook. For those familiar with Python, we first create a dictionary where for each page we build a list of text boxes objects with the recognized and computed values. Then we created a masking dictionary to exclude existing pen strokes at the same location, and we called a function to apply these to the binary file. So when we refresh the Forms folder, you can see that we have a new notebook. Let's copy it over onto the Supernote. Let's refresh to force the Supernote to regenerate everything by selecting and moving a bit the selection. And there you go. You can see that you have real text box objects. Same thing for the next page. I can select it and then just move it a little bit. To prove that those are actually text boxes, I can double tap on them to edit, and here I have the total for the budgeted and actual amounts. I don't have a total actual amount on the second page because I'm missing a value for the meals here. Now let's do the same with the garage invoice. This time I'm going to run the script without comments so it's not too cluttered. Let's copy the new notebook onto the Supernote to show this shiny new notebook, and voila! All that is cool, but our objective was to facilitate data extraction. So let's open the garage folder that was created. We can see that there is a new database. Let's open it. These are the 3 invoices that we had. I can click on a vehicle. I can go back and see who was the client. Look at that database diagram. All this was built with just our syntax interpreter. Now you can ask any IT or AI agent to make sense of the collected data and export it to another database. Now remember what I said about the Python data model. This is an object representation of our data. If I open model.py, you can see that the script generated all these classes for us, like they are in Django, meaning that you could manipulate your data through these objects, and you're essentially ready to build a web interface to interact with your data if you fire up a Django server and use this module. All right, folks, we are almost done with this video. If you liked it, please hit the like, subscribe, and notifications bell. I hope you share my view that e-ink devices can be used as handwritings input. Let's finish the demo showing how changing the handwritings updates the database. This time we build a simple pivot table and pivot chart in Excel using Power Query with an ODBC connection to our database. Thank you for watching, and don't hesitate to leave a comment.